I needed a way to visually storyboard narrative content without spending hours on bespoke artistic commissions or struggling with complex image generation prompts myself. My goal was to take a simple textual description of a scene like a lone astronaut stands on a red Martian dune, gazing at Earth in the distant sky, and automatically turn it into a high-quality, cinematic still. The challenge wasn't just generating an image, but generating an image that consistently matched a desired aesthetic and could be integrated into an automated pipeline. I found that human-in-the-loop steps, while sometimes necessary, are often the biggest bottlenecks in any content production system. So, the less manual intervention, the better. This led me to explore what was available for programmatic image generation, specifically focusing on models that excel at photorealism and cinematic quality, without requiring a doctorate in prompt engineering to get a good result. It also had to be affordable for an indie developer scaling up a few internal projects. My search quickly led me to Replicate.com. While there are many ways to access image generation models, Replicate offers a clean, API-driven interface to a vast catalog of models, including many cutting-edge ones. What appealed to me was the serverless, on-demand nature. I don't want to manage GPU instances or worry about model deployment. I just want to send a prompt and get an image back. Replicate handles all that underlying complexity. It also provides clear pricing per second of GPU usage, which is critical for cost prediction. For image generation, the key is finding a model that produces the desired output with minimal input complexity. Stability AI's Flux model, particularly Stability AI/Flux Pro, caught my attention for its stated ability to generate high-resolution, photorealistic images efficiently. This seemed like a perfect fit for turning my scene descriptions into cinematic visuals without over-engineering my prompts. Let me walk you through the core Python implementation. First, you need a Replicate client. This is straightforward. Import Replicate. Client equals replicate.client, epitoken equals your epitoken. Then, for the actual image generation, it's a call to client.run. The model ID for Flux Pro is Stability AI/Flux Pro :4,034,873 D90 at 1923 425,663,673 F324 D45 D309 C3B 77,823 59,074 A382 CFC. The input dictionary is where you pass your prompt and other parameters. For cinematic stills, I found aspect ratio equals 16:9, output format equals JPEG, and seed for reproducibility to be most important. A typical call looks like output equals client.run Stability AI/Flux Pro :4,034,873 D90 at 1923 425,663,673 F324 D45 D309 C3B 77,823 59,074 A382 CFC. Input equals prompt, Messina description, aspect ratio, 16:9, output format, JPEG. The output object is an iterable that yields URLs to your generated images. I usually just take the first one, which is typically the highest quality. This simple structure makes it easy to integrate into any larger automation script. One crucial aspect I discovered was prompt engineering, even with Flux's supposed ease of use. While a simple description works, adding a few strategic keywords significantly improves the cinematic quality. I found that appending phrases like cinematic still, professional photography, film grain, subtle volumetric lighting, anamorphic lens flare, moody atmosphere, 8K, highly detailed to my base scene description transformed good images into great ones. I didn't want to manually add these every time, so my Python script automatically appends these modifiers to whatever base prompt I provide. This ensures consistency across all generated images and frees me from remembering to include them. It's a small but powerful piece of automation that makes a big difference in the final output and maintains the desired cinematic style across all generated scenes, regardless of their specific content. For the actual pipeline, I maintain a simple JSON file or a SQLite table with my scene descriptions and their desired output file names. My Python script reads this list, iterates through each entry, constructs the full prompt, calls the Replicate API, and then downloads the resulting image. Error handling is built in, including retries for transient API issues and logging for any failures. Once the image URL is returned by Replicate, I use requests.get to download the image bytes and then save it to a designated output folder. This modular approach means I can easily swap out the image generation model if a better one comes along, or integrate this into a larger content creation system that might also involve script writing or video editing. The output images are stored locally, ready for review or further processing in a video editor. Let's talk about costs. This is often the unspoken elephant in the room for AI automation. Replicate's pricing for Flux Pro is around $0.0006 per second on an A100 GPU. A typical 16:9 image generation takes about 5-8 seconds. This means each image costs roughly $0.003 to $0.005. If I generate 100 images for a project, that's less than 50 cents. Generating 1,000 images would be around $5. This is incredibly cheap for high-quality, custom visual assets. It's far more economical than stock photography subscriptions or commissioning an artist for every scene. This predictable, usage-based cost model makes it viable for my internal projects and for generating visuals for my faceless YouTube channels, where I might need hundreds of unique images per month across various videos. The cost scales linearly with usage, which is exactly what I need. The results have been impressive. I can now generate a consistent visual style for my narrative projects, from sci-fi to fantasy, simply by writing scene descriptions. This accelerates my storyboarding process dramatically. Instead of sketching or searching for stock photos that are close enough, I get precisely what I describe, in a high-fidelity cinematic style. It's not just about speed, it's about creative freedom and consistency. For my automated YouTube channels, this means I can now easily add custom, high-quality visuals to accompany narrative segments without breaking the bank or spending hours manually sourcing images. This pipeline effectively turns textual story outlines into visually compelling video segments, almost on autopilot. It removes a significant creative bottleneck and makes it possible to produce rich visual content at scale. This project is a prime example of how targeted AI integrations can solve real-world production problems for indie developers and content creators. It's not about replacing artists, but about empowering creators to move faster and visualize their ideas with unprecedented ease and cost-effectiveness. My next step is to integrate this image generation pipeline directly into my larger YouTube automation system, so that when a new video script is generated by Claude, the relevant scene descriptions are automatically fed into this Flux system, and the corresponding images are ready for video editing. If you're interested in seeing more of these practical AI automation builds, or if you'd like the Python code for this particular Flux integration, let me know in the comments below. Hitting my next subscriber milestone helps me continue sharing these real-world projects and the code behind them. Thanks for watching.